Hello everyone, this is Shyam Babu, Assistant Professor, Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad. In this today's session, we have discussed bandwidth and power calculations of DSB-SC. Bandwidth and power calculations of DSB-SC. Then bandwidth and power calculations of DSB-SC and DSB-FC, nothing but double sideband full carrier versus double sideband suppressor carrier comparison. So, you go for first one, DSB-SC power calculations. We have to take the complete equation of the DSB-SC. We know S of t is equal to AM AC by 2 cos 2 pi FC plus FM into t. This is upper sideband. And AM AC by 2 cos 2 pi FC minus FM into t, this is the lower sideband. Then only it is called as a double sideband because there is no carrier. The carrier is suppressor. That's why the full name is double sideband suppressor carrier. Then the power of the DSB wave is equal to sum of powers of upper sideband and lower sideband frequency components. When you are doing the power analysis or the power calculations of AM, on that time we discussed PT is equal to PC plus PUSB plus PLSB. But right now, we are calculating the power of total power is equal to PUSB and PLSB. PUSB and PLSB. Just compare these two difference. In the second term, there is no PC. The carrier is suppressed, that's why there is no carrier power in the case of double sideband. Automatically, the power of the carrier should be suppressed means only that carrier power is reduced means automatically it is an advantage. The power is reduced. Any information is lost means no, because the carrier does not contains any information. That's why PT is equal to the total power of the double sideband suppressor carrier is equal to, this is AM point of view and this is DSB-SC point of view. The PT is equal to PUSB plus PLSB, power of the lower sideband. We know the standard formula for power of the cos signal should be, we know AC point of view power calculations. AC square, nothing but input square, nothing but here RMS value you are taking, RMS components. That's why RMS when you are taking the, for example, VM by root 2 whole square by R. Already these analysis, VM by root 2 whole square by R. That means, first let us find the powers of upper sideband and the lower sideband one by one. First you can go for the upper sideband. What is the amplitude of the this one? This is nothing but amplitude AM AC by 2. Here therefore AM AC by 2 root 2, nothing but here this indicates simply amplitude levels. That's why AM AC by 2 root 2 whole square by R. When you are doing this analysis, AM AC by AC square by 8R. AM square AC square by 8R. This is upper sideband. Likely, if you go for the lower sideband, observe here, this is the upper sideband, and if you go for the lower sideband amplitude also AM AC by 2 only. AM AC by 2 only. That's why the power should be AM square AC square by 8R. Same as AM square AC square by 8R is the power of the LSB also. That means the USB power and LSB power same because the amplitudes are same, only the bands difference, FC plus FM, FC minus FM, but the amplitude should be same. Here AM AC by 2, the amplitude of upper sideband is, and AM AC by 2, amplitude of the lower sideband, both the amplitudes are same. That's why we got the powers, because we are taking the power calculations. When you are doing the RMS value, you can take the amplitude levels only. That's why AM AC by 2 root 2 whole square by R, that value should be equal to AM square AC square by 8R. Here also LSB point of view also AM square AC square by 8R. Therefore, you know the USB power value and LSB power value. Then you can add both the values, then it is called as the total power of the DSB-SC. Therefore, PT is equal to USB power, and this is the USB power, and this is the LSB power. Then it is equal to AM square AC square by 4R, because it is add 2 AM square AC square by 8R, then it is equal to AM square AC square by 4R. Clear? When you taking, actually in the case of amplitude modulation, the total power is equal, PT is equal to AC square by 2R, AC square MA square by 8R, AC square MA square by 8R. When you are doing this equation, PT is equal to PC into 1 plus MA square by 2. Here there is no carrier in the case of DSB-SC. That's why PT is equal to what you have got? AM square AC square by 8R, AM square AC square by 8R. Then the value should be equal to AM square AC square by 4R. This is the total power of the DSB-SC. Then you need to next parameter DSB-SC bandwidth calculation. First of all, you need to know the definition of the bandwidth. What is the bandwidth? Simply, the bandwidth is the frequency parameter. Bandwidth units are hertz, and it is higher frequency, the difference between higher frequency and lower frequency values. Higher frequency and lower frequency. Higher frequency means maximum frequency and lower frequency is minimum frequency. That's why here the bandwidth is equal to F maximum minus F minimum. F maximum minus F minimum. Then consider the equation of DSB-SC modulated wave. Then you know why I am writing here. S of t is equal to M of t into C of t, where M of t is nothing but AM cos omega mt, and C of t is nothing but AC cos omega ct, where omega m is nothing but 2 pi fm into t, omega c is nothing but 2 pi fc into t. Then you can multiply these two, then that should be equal to AM AC cos 2 pi fm into t, cos 2 pi fc into t. Then that should be equal to, when you are doing the analyze, AM AC by 2, 2 cos A cos B, cos of A plus B plus cos of A minus B. Then AM AC by 2 cos of 2 pi fc plus fm into t, AM AC by 2 cos of 2 pi fc minus fm into t. Then what is the DSB-SC here? The DSB-SC modulated has only two frequencies, nothing but fc plus fm maximum frequency, fc minus fm, that is the minimum frequency. That is, f maximum is equal to fc plus fm, f minimum is equal to fc minus fm. You can difference these two, f maximum minus f minimum. Automatically what happens? fc plus fm minus of fc minus fm. Then what happens here? fc plus fm minus fc, minus into minus plus fm. Plus fc minus fc get cancelled, then it should be equal to 2fm. That means the bandwidth of the DSB-SC should be equal to 2fm. The bandwidth of the DSB-SC is 2fm. That is, thus the bandwidth of the DSB-SC wave is same as that of AM wave, and it is equal to twice the frequency of the modulating signal. The bandwidth is same like AM. AM in the case of amplitude modulation also, the bandwidth is equal to 2fm. 2fm. Then go for the comparison point of view. DSB-SC, it is also known as double sideband full carrier. Nothing but R amplitude modulating signal. Okay, AM or DSB-SC, because the carrier is present. That's why it is called as a DSB-SC. And we go for the next one, DSB-SC double sideband suppressed carrier. We go through the parameters one by one. First parameter, the carrier suppression. The carrier suppression. Then you need to observe the, for better point of view, S of t in the case of AM, AC cos omega CT plus AC MA by 2 cos omega C plus omega M into T plus AC MA by 2 cos omega C minus omega M into T. This is the AM equation, and you go for the S of T for DSB-SC. It should be AC AM by 2 cos omega C plus omega M into T plus AC MAR AM by 2 cos omega C minus omega M into T. Omega M into. So this is the DSB-SC. S of T of DSB-SC, and this is S of T of AM. Just compare these two equations once you can define the parameters. First one, carrier suppression. Observe here, DSB-FC is nothing but AM. Then the carrier is suppressed in the DSB-FC means here the carrier is present. That's why there is no suppression. And you go for the double sideband suppressor carrier. Here in this equation there is no carrier term separately. That's why the carrier is fully suppressed. The carrier is fully suppressed. Then go for the sideband suppression. In the case of AM, this is upper sideband and this is lower sideband. Two sidebands are present. Okay. In the case of DSB-SC also, upper sideband is there and the lower sideband is there. There is no suppression of the sidebands. That's why the sideband suppression are not there. And third one is bandwidth. The bandwidth is, in the case of AM, it is equal to 2 FM. In the case of DSB-FC also, it is 2 FM. Both are same. We do the analysis also in the previous slide. And next one, the transmission efficiency. The transmission efficiency in the case of DSB-FC or AM, it is minimum. When you are taking the FM, sorry, in the case of AM, it is minimum. In the case of DSB-SC, the value should be a moderate value. Comparing with the DSB-FC only. And here, number of modulating inputs. We know very well, modulating inputs is nothing but a message signal inputs. How many you are giving? Only one input signal. That's why in the case of AM 1, in the case of DSB-SC is also 1. Then what are the applications especially? We know very well, the AM applications can be broadcasting point of view, especially AM radio broadcasting, or with respect to frequency, high frequencies. These applications are mainly useful in the case of radio broadcasting applications. Radio broadcasting applications. And power requirement to cover same area. Same area. What is that? High. Because the carrier is present. Here it is the medium. The carrier is no. But we go for one more method. On that case, you suppress the one more sideband. Then automatically having less. And the complexity, it is simple. Both are, because only you are giving the input should be message signal, and one more is carrier signal is given to the either balanced modulator or a ring modulator. It is simple circuit, understandable. And in the case of AM also, square law modulator. Therefore, these are a small circuit with the demodulation process of a little bit of filter should be added. We got the modulating signals as well as demodulating signals. Then comparing these all parameters, either carrier, bandwidth, transmission efficiency, modulating inputs, applications, only the main difference we are observing here, the carrier suppression is completely suppressed in the case of the DSB-SC. That's why the differences we are observing in the case of power requirement, because the carrier is suppressed, that's why the amount of power of the carrier should be reduced in the case of DSB-SC. Then, in this session, in this lecture, we discussed about the bandwidth and power calculations of DSB-SC. The bandwidth is of DSB-SC is 2 FM, and the power calculations, you know, AC square, MA square by 8, 4. If R is equal to 1 kilo ohm, then AC square, MA square, IC square AM square by 4. Then these things are covered, and in the case of next session we discuss about SSB-SC, nothing but single sideband suppressed carrier. That means in the case of double sideband suppressed carrier, the carrier only suppressed. We had the two sidebands, but in the case of single sideband suppressed carriers, you can suppress carrier as well as one sideband. Carrier and one sideband. That's why the name it is called as single sideband suppressed carrier. Thank you very much.